Welcome to Black Hat Windows Security Conference 2002, held February 7th through the 9th in New Orleans, Louisiana. The following videotape was recorded live at the conference and produced by the Sound of Knowledge Incorporated.
WhiteHat Security specializes in web application security, so I basically live on port 80 and HTTP most of the day. So today we're going to be speaking on some web application security topics, a little bit different from what Foundstone presented in one-way SQL hacking. Basically we're going to do two things. One is talk about web application security, some common attacks, and also we'll be releasing a tool called WhiteHat Arsenal. It's basically a suite of tools to aid in penetration testing a web app, and that'll take part in the second half of the presentation. So we'll just go right for it. Oh yeah, if anybody has any questions about anything, wants me to talk in depth about any topic related to web application security, just go right ahead. So the first four things we're going to cover besides the tool basically is the web application security landscape, why web application security is important, and if you didn't think so, you probably wouldn't be in this place. Common web application security mistakes, for instance, the first things you look for when auditing a web application, quickly how to find things wrong, and things like that. We'll also be covering some web application attack methodologies, high-level attacks relating to web application security. For instance, as far as web applications go, there's about, 15 to 20 or so types of attacks, but the attacks are not really well defined. There's lots of permutations of each attack. As far as parameter tampering goes or cookie manipulation, you can take all different kinds of routes with web application security, so it makes it a pretty complex environment. So what's the landscape? What exactly are we talking about? Well, basically, in the last, 4 or 5 years, as far as e-commerce has come on the web, become quite accustomed to shopping, auctions, banking, stock trading, webmail, all different types of systems. They're just kind of second nature. We have, the entertainment category. We have message boards, webmail, guest books, voting polls. You can do anything with a web application. Basically, if you can get it to a web server, chances are you can turn it into a web application. And then, as we go forward, we're already seeing this now. We have the just plain crazy category. As we start to, make a printer web-enabled. I mean, who needs a printer with a web server on it? So I just thought that was kind of crazy when I saw that. PDAs, cell phones, and people are doing system configurations right through their web apps. Got to tell you, it's really, really dangerous unless you really know what you're doing. I see it everywhere now. And then there's .NET and password, and that goes without saying. So it's a good understanding when I speak about web applications, what exactly I mean. The simple definition is how I describe it is a web application or web service is a software application that is accessible using a web browser or HTTPS user agent. But the easier definition is, because the last one doesn't always fit, is if it runs on port 80 or port 443, uses HTTP, it's probably a web application. So you're not exactly stuck to port 80 or port 443. You can put Apache on port 81 or 8080, whatever it is. As long as it runs HTTP or HTTPS, it's a web app. So as far as the framework goes and how web application fits in as far as a layered view, at the top there you have the user. And separated, here's the layers, there's the dangers on the right. You have the user. And that's at the client level. Between the web server, there's the firewall and there's the transport layer. And you see the dangers there, passive monitoring, man-in-the-middle attacks, session hijacking. Then we go a little bit deeper and hit the web server. Normally, or a lot of times, I won't say normally, you have web applications that now sit on top of the web server that interact with the system's resources. Then, on a lot of installations on big platforms, you'll have another internal firewall and a database backing it. And as far as all the layers go, here's some of the common attacks that apply to each and every level, so it's a nice breakdown. Now, The thing about web application security and common security measures is that when the user connects to the web server, they're traveling over port 80 or port 443, and if anybody's familiar with a firewall, which I'm sure most of you are, that a web server opens port 80, and at that point you're allowing all traffic to go through. So the firewall at this point becomes absolutely useless when you open it up. Firewall does absolutely nothing to guard any web apps whatsoever. They just, the job of a firewall basically is to, keep, as people put it, keep the bad guys out and let the good guys in. Well, web apps, the challenge is to let everybody in and make sure they play nice. So it's a whole new set of rules. How to put this in there? Basically because I get this still a lot. Mostly with people I'm buying stuff from. I just want to see if they're secure, they're doing some good stuff with my credit cards. They say, well, we use SSL, we're secure. And to which I sarcastically answer, well, good, you're encrypting my attacks, so you can't see them either. So SSL is good, don't get me wrong, it's nice to have things hidden in transit, but just because it's SSL does not mean it's secure. It's just one more thing you have to do in everything. So from the basics, why is web application security important? Well, it's important for a lot of reasons other than this list, but basically it's a very, very, very easy way to compromise hosts, networks, and users. For the most part, we've had a long time of dealing with network security issues, firewalls, and host-based compromises and such. As far as web application security goes, there hasn't been a whole lot of work done on it. I mean, we've only been in the idea of securing web apps for maybe a few years. So it's just a really easy way to go and crack a system. Web applications are widely deployed, basically because the use is really, really good. And they're everywhere. I mean, like I said before, you can gain access to Compact Asset Insight. They configure their systems using web apps. Most attacks, when you're attacking a web application, either it's not logged, or at least the payload isn't, or no one's looking at the logs anyway. Who looks at access logs for the most part to see weird web attacks? You might catch a common scanner going, but complex, very custom attacks are just going to blow by everything. And as far as the post request goes, even in post requests, you don't really see the payload coming by. It doesn't get logged, so you don't see these attacks coming. They're incredibly hard to defend against. Basically, web applications take multiple inputs. They're widely deployed, so it's really hard to get these things secure, especially on a big system. Hopefully it's still not most, but most people I think still don't think of securing their web applications, and when they do, they really have a hard time trying to figure out what exactly that means or how to go about it. Intrusion detection is a joke. It's not really a joke as far as network security goes. Intrusion detection has its place, but I've rarely seen, almost never seen, intrusion detection block any good web attack. Basically, they don't look at port 80 as far as the payload goes to see it's an attack. Basically, it's a port 80, it's a valid web request, it gets allowed, so it goes in. As I said before, firewalls. What firewall? I didn't see a firewall when I typed in a link into my browser. Then the encrypted transport layer doesn't do much at all except hide the attack. And so basically all these considered, how much easier can it get? And then there's the notorious Unicode, which you can, we saw during Code Red. The common mistakes that I see out there in the field, basically trusting client-side data is number one. As soon as you trust client-side data in a web application, you're going to get burned. Never, ever do it. Escaping special characters, that's going to be number two. Basically, if you could pass shell characters and get them to execute in weird ways, you could change the flow of an application or get other things to execute. HTML output character filtering. This goes into cross-site scripting, which I'll try to cover in as much depth as I can. Then there's web applications that run as root. Very bad idea. Very slim times does a web application need to run as root, so try not to do it. Then fifth on the list there is ActiveX JavaScript authentication. This goes to the trusting client-side data. If you're doing authentication in the client, chances are it's not going to work very well, so try not to. Then there's a lack of authentication performing critical tasks. For instance, this goes into the cross-site scripting category, which I'll explain how a cross-site script takes control of a browser. Basically, logging in is one thing, but a lot of times a logged-in user can perform a lot of critical tasks or important tasks, and you want to be able to re-authenticate or revalidate that the user is actually making that request or wanting to make that request before you move on. So right now, okay, so we covered trusting client-side data. As far as what you want to do in this case, from an application standpoint, what you want to do is know exactly what your application is expecting to receive, develop your allow lists, and do not allow anything else. Then there's the unescaped special characters. Here's an example. In the path here, we have foo.com, then the CGI, and it takes a string. Basically, the string is performed a search into the database, okay? Basically, if you're trusting client-side data, a very quick hack on that CGI is you could search for you could change the string, change the database by parent directorying up, and you can search the password file for whatever you want, or just dump the password file. This still happens a lot everywhere. Basically, a lot of people still don't feel the need to take slashes out of the strings or disallow the connection or whatever. But basically, it's a very simple parameter attack that works a lot of places. You even see a lot of scanners picking this up now. So what special characters to look for? Well, as many as you can, but here's a good list. Depending on what operating system you use, these are the common ones here, so you have to escape all of them. HTML character filtering. This is one of the things you have to do when you're taking client-side submitted data and echoing it to the screen. What you're going to have to do is these characters here. There's probably more as defined by CERT, but here's the really important ones. That you're going to have to turn the characters on the left into their equivalent HTML entities on the right. Just doing this simple thing will, on every parameter that echoes to the screen on a web application, will stop 99% of cross-site scripting exploits. So this is very important to do. Then there's the null characters should all be removed. I have never seen a legitimate reason to put null characters in a parameter string, so just remove them. Let's see, do we cover these? Yep. Oh, the last one here. Hosting uncontrolled data on a protected domain. Many web page hosters have to deal with this just by the nature of how they do business. Basically what it means is if you're allowing users to host data, like for instance, even an auction site might be might fall into this category. For instance, somebody puts up an auction page, they put up images, they put descriptions and stuff. Basically, you're hosting their uncontrolled data on your domain. If at all possible, put their information on a separate domain, because if they're allowed to input data on your domain, it's uncontrolled and you have no idea what they're putting there or what that data can actually do. So, let's see here. Actually, I'm just going to go right into Arsenal. Arsenal is something that WhiteHat's been using internally to perform penetration tests probably for the past 6 months. It basically just started as a need to be able to do our jobs faster, and never really had any intention of releasing it until I showed it to a couple of people that threatened me to give it to them. So a couple of weeks ago, I was talking with Jeff, and said, asked me if I wanted to speak, and I said, yeah, but I'm working on a tool. He goes, well, why don't you just release it there? So, and I quickly said yes, but the problem was it's a Windows security conference, and I live on Linux, so I had to quickly port it over to Windows in about 2 weeks, so you have to forgive some of the bugs. But I think right now, I think FX is probably porting it back over to Linux for me, so we'll talk to him later. Let's see. So Arsenal has a GUI-based web interface. It works completely within the browser. It's session-based. We put a lot of work into the discovery-based utilities. It has active assessment, and I'll explain what that means. It has encoding and decoding, and we're very proud of the reporting features. So let me see what I got on the next slide here. So we'll just go right into it. So basically the way Arsenal functions, it itself is a web application. It runs currently right now on Apache Win32. and it needs Perl to run. Basically install Apache 132 and active Perl. It'll run pretty simply. Basically you put some HTML files in a directory, and I can show you that, and some CGIs into another directory, and you're all set to go. This directory here that I'm highlighting, that's all the HTML files that it uses. So it'll come in the package, and all the CGIs go in there. So you just drop 2 directories in, and you're ready to go. So here's the web interface, and I'll explain what some of the interface is. Up in the top there's the current session request method. Okay, basically the whole thing's session-based. We use sessioning basically to keep track of what we're doing as far as the logging goes, so you can see, you can separate your workload. It's helpful for any web application security consultants in the audience. You could change the request methods. Right now we only support 3 of them, since we don't know how to properly handle the output from different web servers and stuff using the other ones. The output mode, there's 4 output modes, and I'll explain each one of them, but it does have full spidering capabilities. Spider is a little bit different from your average run-of-the-mill spider, and it has a bunch of different modes. It also has a cool little attack labeling system, where depending on what you're doing in the system, you can actually label different attacks or different things you're doing in the tool as with different labels. The top field there is the target, and you can also add in HTTP request headers. Basically, what it's kind of doing is giving you a pretty good graphical user interface to HTTP. So you can manipulate everything on the fly as you see fit. So the first thing we'll do is create a session. So basically, this is the session management system. We already have a session created in there, and I'll show you how to create a new session. There's a session name, session description, and then there's all your log files in here, and most of them are all in XML. Makes it a lot easier. So we'll create a new session. We'll name it WhiteHat 2. Okay, so now we have WhiteHat 2 in there. Then the next thing you do is you click Set Session. And if you look in the top left there, it put up your current session on what you're working on. Now, we'll cover some of the forced browsing scans. Basically, forced browsing is kind of a generic term for forcing URL requests to a domain. Basically, actually, I'll just point it at WhiteHat. Hope they don't mind. There's 3 different types of force scanning this supports. This works off config files in the tool itself, and you can add or delete files. Basically, this right here will look for common directories in the system, whether they exist or not. And we'll watch as the results come up. Basically, what force browsing does is, it doesn't matter if the page is linked in or not. This will search a big list. However, I have a default list in there, and it'll look for what files exist and what directories don't, and it'll tell you the HTTP response. So basically, as it turns out, most of the pages are going to come up 404. But you're just looking for the 1 or 2, like the /admin directories that might point to something cool where people are trying to be clever and hide it. So, test. It probably is. It's alphabetical, so we'll see as it comes up. There's /new. Not on WhiteHat.com. Anybody got a URL? So we saw a /test there. So now that it found one, we can go see what that looks like. Hey. What is this? Hey. So it's just simple force browsing attacks. But the cool, actually we designed this thing to be okay. Actually, before I go any further, I'll tell you what we designed this tool for. Is there's a need for web application security scanners out there. Everybody attests to that. Most of the scanners out there that I've seen and tested, and I tested just about all of them. My previous life, I used to work at Yahoo, so basically my job was to be in charge of 200 web-based properties and 180 million users, and I saw every scam artist, script kiddie hacker, I saw everything on the planet. and trying to keep up with the amount of exploits was pretty rough. So I tried everything. Basically, what the scanners out there that did, they just blindly try to inject with some kind of artificial intelligence, things into the parameters, and they give you like a billion output, a billion, responses. This looks like this looks like that, and you start clicking on the links, and it has no idea what it is, and neither do I. The problem with the scanners, as far as a conceptual model goes, is that in a web application, when you're trying to manipulate it or get it to do something it wasn't intended to do, is that it's hard to define what expected behavior is. If the app does not know what that web application is supposed to do, how can it tell you whether or not it was exploitable or not? Basically, there's still going to be the human element. So, for instance, if we, you kind of think back to that parameter tamper I showed you. If I just gave, if I actually, tested a lot of these tools, and I specifically put really easy exploits in my code, and the web application scanner didn't find it. It didn't know to find it. It didn't know it could // up and change it didn't even know it was a database file. It just didn't know. And it's not to be expected to know. So the idea we took with this was, as far as, I felt I knew what I was doing. Other people felt they knew what they're doing. There's just no way to do these attacks that were just basically simple attacks fast. You're always digging around the command line, making simple Perl utilities and stuff. And, everything was very cumbersome. So we decided to put a graphical user interface and make it very generic. And people can tweak it to death and do whatever they want with it. So our job, didn't become to tell people, these are the exploits you want to run, because every web application is different. We built a tool basically so you could throw whatever you wanted at it and be smart with the tool and just be faster at it. So, okay, so let me go back. So we'll search for common log files so you can see what that looks like. So basically, I just put together a big list of, a lot of lists and see what log files I could find. And, most of the time, they come up 404. You're just looking for the couple that matter, And so actually what we'll do now is just stop this prematurely, and we'll go back into the session manager. So basically, if your job is like, whether you're a QA tester, a web security consultant, or whatever, you can, show the log. So in session manager here, it tells you your HTML results of all your forced browsing attempts and keeps the log persistent. So you can put this in your report or whatever, give it to your boss or what have you. Look, boss, I found this, and look, boss, I found that. So everything is stored in all HTML, nice, and you can go to anything you want and have a ball. This is also a cool little utility, backup file suffixes. If you have an inclination, like something like default.asp or whatever, exists, and in WhiteHat it's not. We can search for common backup files that usually get left in the system really quickly, so you don't have to run Perl scripts to do it all the time. You just press a button. So they'll all come up 404, but basically what it does, it just appends backup file suffixes to the end of the URL, so you can find backup files really, really quick. So that's forced browsing in and of itself. Let's see here. Right here, I'm going to pull down. This is what we call rip and rewrite mode. Basically, what it does is it's going to pick a target, you put whatever headers you want in it, and you hit send. And what it does is it looks for forms in the web page and that are hiding. Tells you what you did if you added any GET query requests. It then tells you what the HTTP response headers were. So you can look at it and see what they mean to you, log cookies and anything like that. The other clever thing it does, it actually rips up each and every form and allows you to edit everything on the fly. It does all the editing for you. And if anybody had tried to hack a form, basically what do? You view source, you look at the page, you cut out all the irrelevant HTML, delete, and forever. Oh, I missed that, so I have to view source again. And you get the forms together.
You can do a base tag, which will reset all the bases as part of the header. I think it's base equals www.foo.com. For the rest of the document, anywhere where it says bar.com.
All right, that's that'd be a good thing to implement. So so for instance, we got the target of where that form was, and I'll show you everybody knows what yahoo.com looks like. It has one search element in it. So basically, it grabs the target, and you can edit everything you want, throw in whatever value you want here, add values here, and submit it back in really, really quickly. So no more view source, edit, inject, reload in the browser, and hit send. This just happens in 2 seconds. So like, for instance, since I used to work for Yahoo, I like to pick on them a little bit. Let's see, we'll go to login.yahoo.com, and I'll show you a little bit more on the power of this. So when you're logging into Yahoo, so basically it's, actually I should start at the top. So it has a whole lot of, you can see they're using P3P, set cookie, and it actually knows to put the cookie in the next field here for you, so you don't have to you can do it automatically. And let's see here. You see all these hiddens here? These are all the form elements that are hidden that normally you have to turn back into text to edit them or implement the value. It makes them all visible really, really quick, really, really fast, so you can see everything on the fly. Just does it all for you in 2 seconds. And I'll show you how to do other things. Like, actually, first let me show you this. So I'll just hit the sign in button so we can generate some logs in the back end so I can show you the logs. If anybody who's a web application security consultant has posed the question, well, you found all these vulnerabilities, but what else did you do? What did you do to my CGIs and everything like that? Basically, as it stands out, most of us just use a browser, start manipulating parameters, and there's no, unless you pull out your browser history, there's no way to tell anybody what you did. Basically, you're just doing it by ear and trying different things, and nothing's logged. So we got fed up with that, and it started logging everything via XML. Basically, we use XML because we didn't know how yet, so we just learned XML and put it in XML. So we'll look at the attempts XML. Basically, what this does is it's an XML backend. It uses an XSL style sheet and describes every single attack that you did, what parameters you put in, what headers went in, what time, and everything, continuously. And we can see the XML on the back end. So that's all the XML data, so basically it'll go forever. You start putting in, you can start putting this in your reports. And if I could show you this, this is a unexpected feature that you can actually copy those. So, and then paste those right in. It makes quick work of report writing. You just throw it right in your Word doc, and that's it. So, the glory of XML. Gotta love it. Okay, so let me show you some other stuff here, back on rip and rewrite mode. So, if you're familiar with parameter tampering attacks, you're probably also familiar with different ways to get past whatever implemented filters that they have. For instance, like if you URL encode a string, you can usually, basically what happens in the code, if you URL encode a string, what the app is supposed to do is URL decode the string and then perform its pattern matches against it. Many times they get it backwards, that they'll check this, they'll do their security testing on the string, like no ... is going in, so you URL encode the ... you bypass the filter, and then it URL decodes it for you, and bam, you're in. So we make that attack a little bit easier. So for instance, if you had some, let's go down here. Some weird value, like we'll take this string, the 7p, whatever the heck that is. We'll do quick URL encoding. Stop. So you click the URL encode, and then click in the field, and you can do encode, decode right in the browser really, really fast, anything you want. So you could type in whatever here, encode it, decode it. Also, when you're working with authentication credentials, a lot of times they'll for whatever the reason, they'll base 64 encode their authentication credentials and ROT13 it or something weird like that. And so basically you can do base 64 encoding and decoding. So you can start ripping apart authentication credentials. And also for good measure, we have MD4, MD5, SHA-1, and the ever-present ROT13. So then the joke goes, you know, don't double ROT13 anything, doesn't hide a thing. Everybody got that? That's pretty bad. Okay, so we got all the encoding out of the way. How am I doing on time here? Where am I? About what, half hour ago? Okay, so what else we got here? So you got force browsing, session manager. Oh yeah, I'll show you some, some cookie injection attacks. We'll just go for login.yahoo.com. So we see the login field there. This is just a simple login procedure to get everybody familiar with how it works. So basically, before the talk here, I registered an account, WhiteHat, New Orleans 2002. Don't look at the password. At least I didn't make it password. So basically, this will actually, let me show you here. You can change the output mode here to basically the other output modes. So basically, what happens in the case of Yahoo, every page is different. Basically, they'll 302 redirect you and set your cookies. And basically, for instance, Hotmail, it works like this, eBay, just about everyone uses some kind of authentication cookies. So it shows you your response cookies. So basically what we'll do here is we'll grab the cookies that we were supposed to pick up, and let's save them. We'll cut off the irrelevance on the end. Yep. For those that don't know HTTP all that well, set cookie gets reverted to cookie when it goes back. So we'll throw the cookies in there. Let's see here. And we'll throw the cookies right up here. And just so you can see it work, we'll throw my in there and go into HTML mode, hit send. So basically, we're successfully logged into Yahoo. So what this means is, yeah, you can log into Yahoo, but that's just a means to an end. Basically, what you can do here is you can do cookie manipulation on just about anything on the fly. So you're working with the authentication credentials. You can start ripping them apart, change the cookie on the fly, see what's valid, see what's not valid, become another user, screw with another user. You can do session replay attacks, session forging attacks, or reverse engineer just about anything you want right in the fly. Basically, I haven't seen another tool that's does this easy. Basically, what you had to do before, and the programmers will tell you, you have to write simple scripts and stuff like that. You have to hard code your cookie credentials in there. You're sitting forever on the command line when you can just do it in 5 seconds with this. So basically, what we built is basically just a big time saver for everyone. So let's see here what we got here, and admittedly, actually, since I only had 2 weeks to port this thing to Perl in active state, isn't the it's a pretty good Perl interpreter, but in the spider here, long-running CGI is like the spidering capabilities, and I'll show you how the output looks to that, is basically, like in the case of spider, long-running CGIs tend to keep running even after you hit stop, so you have these rogue processes running around. I don't know how to stop them, so I'll buy a beer for anybody who tells me how. So let's see here. Let's go back to the default. Yeah, remove the host header. And we'll spider yahoo.com. So basically, this spider does a couple of things different from the average run-of-the-mill spider. Sure, it picks up URLs. Hurry up. Sure, it picks up URLs, but what good is a URL if you don't know what's in it? So basically what this does, it tells you the IP address of the domain, the host name, the content type, the protocol that was using, the port, if it was on domain, the method used, if the page had comments, scripts, how many links, if it had forms, the date you did the request, and what the response was. So it tells you everything about the page that a web application security person needs to know. And on the left here, you'll see a bunch of T's. Since we didn't have time to do images, you're left with letters. Basically, T stands for target. And email addresses will have M, off-domain links will have O's and stuff like that. And the cool part about this is we also, so you can click on the link and go to that page. Or you can throw, let's find a page with a form in it or something. Form, yes, weather. If you click on the T there, it actually throws the target up into the above. So, if you're interested, you can go to that page, then rip and rewrite it on the fly like that. So now you have the spider links, and you can go each page, sequentially until you hit them all. Now, that might be enough, to get this much, but we went a step further, and we're actually defining every single page and describing it in XML. And as we do so, we're actually picking up every CGI and describing those in XML too. So if we go into Session Manager, we'll check that out. So we have the Spider XML document. Basically tells you every single page, all the response headers that came back, how many links. So you can start doing nice stats on what each page had within it, and you can start screwing around with everything. Basically, not only is this good for web application security scans, but it's actually also good for web developers and QA people and stuff like that, because most of the time, Spider's out there, you'll get a directory structure, but you have no idea what's in the page. So yes, this is a security tool or helps with security, but it's also very good for developers as well. As we found out, actually we had no intention of making it for developers, but developers liked it too, since you could perform, I didn't show you, but you could perform method manipulation attacks, so you don't have to hard code it in. They can just start stress testing their apps right out of the box easily and fast. So all the Spider results are stored in XML, and so you can import them back into Word if you want to. Oh,
How deep does the Spider go?
All of it.
It's recursive infinitely, or?
Oh, well, basically it keeps a big array. And it doesn't go over the same URL twice, if that's what you're asking, but it'll exhaust until it doesn't have any more in the list that it builds for itself. Basically, it grabs a page, gets the results, shoves all the links into a big array, and goes to each one. It sticks on domain.
Okay, so it doesn't convert domains, but it's infinite within domain.
It won't stick to subdomains. Like if I target it at www.yahoo.com, it won't stay on www.yahoo.com. It will go to weather and everything like that.
Right.
Okay, but if it tries to go to news.com, it won't. It'll tell you that it found that link, but it won't go there.
Okay.
So.
But it will give you everything that there is underneath Yahoo.
Everything. So I haven't had the nerve to try that indefinitely. I had it running for 3 days and I had to find the end. So. And the problem was, the log file got so big, it took me forever just to load it into XML. Yes, it spiders and shows you the XML results. It also describes all the CGIs that it saw in XML. So you can actually see every single CGI, what it saw, what it's taking in, and it's all described in XML. So the idea is that if you want to write some kind of scanner, if you want to see, scanners will go blind. They don't have no idea what that CGI is supposed to be taking in if it's custom. Sure, they'll be able to find for known vulnerabilities, but as soon as you change a variable name, they're screwed up. So since it's all stored in XML, you can actually manipulate each parameter in there individually and start a framework for building other tools. So since it's all XML, it gets pretty easy. So if you just go down the list here, you can see the IP address, the protocol that was using, so you can stick to the right protocol. You can see every single parameter. Just has everything. So, and it's always cool to view the XML so you can see what it looks like in the back end. For whatever reason you guys don't like our style sheets, write your own. One drawback, we're using XSL. Currently IE is the only browser that does support XSL. Netscape, Opera only support CSS. I forget what layer, but So basically, when you view it in like a Netscape or something like that, it'll give you a big glut of data that doesn't look like anything. So IE is the preferred browser of choice for this. Okay, so what else didn't I show you? Every single CGI. Basically, what it's looking for is a question mark. If it has a question mark, then it's going to see it. Let's see here. So we have everything in Session Manager. Oh, okay. So I should show you. Let's see here. Whether let's go to rip and rewrite mode. Okay, so we're back here into rip and rewrite mode, and see you can change the attack label, so you can organize your attacks by attack label. You can change the method here and post into it instead of just the standard gets or whatever. You can do whatever you want. So, for instance, you see this right here? This is a good thing. That method was not supposed to be allowed into that CGI, and it told you so. So you can do your method manipulations really quick. Most of the time, if you're developing secure web applications, know what methods you're supposed to receive, and don't only allow those. Okay, so for instance, don't just allow any arbitrary method into your CGI. And let's see here. Here's one I found today with Tim Mullen. He kind of got me with this one. If you don't know Tim Mullen, he's currently giving the SQL talk in the other room. Tim Mullen runs Hammer of God. And so I was just looking around, testing the tool out. So I go, let's rip and rewrite his page. So apparently what Tim did is he put some kind of image inside of his response header. So technically you're not supposed to be able to do that, but he did. So you could find really weird stuff in somebody's response headers. So what I should have done, and which I'm just tempted to leave, is I'm supposed to escape the HTML coming back at me. So it turns out I am cross-site scriptable. So, but it's kind of neat how he did that. So I just left it, and I told him I'd show it off. Let's see what else we got here. So, and also got to show off, some of the stuff you just don't see around that's just cool to screw around with. So let's go to Slashdot. Slashdot has these interesting response headers. So if you see let's see here, Xbender, bite my shiny metal ass, okay? And and every time it's different, so I just thought that was cool, when it was coming up. So I showed you all how you demos. Oh yeah, so that's the tool, and then we go back into the presentation here, which would be a good time to do so. So let's see, I showed you all that. Let's see. So basically, the tool's very good for the force browsing, the spidering, all the XML stuff, the rip and rewrite. It's very good for gathering discovery. All the rip and rewrite stuff and the different modes and stuff allows you to do just about every type of client-side data manipulation, that you can think of. The only thing it really doesn't do, because I didn't have the functionality in the modules, is I can't do HTTP version, get / and then the version. I couldn't change the version. So at spiders, you can look for identifiable characteristics. These will be defined as, comment lines. For instance, if you're looking at the spidered page, if you're seeing a bunch of ASPs, chances are it's not a Unix machine running Apache. So if you look logically at that, you can see it's an IIS machine running or whatever service running, because you can see the response headers coming back. You can look at error and response codes automatically, to start changing your methods, and you can see the response codes coming back and try to glean data out of the system. And the file application enumeration, that's force browsing, and you've seen all of that. It can give you a nice site map, service map. You can find hidden services, CGI forms. You can find email addresses. Actually, what I didn't show you is that, let's see here, is that you can go into source mode. Sure, you can view source on the page, but it's always cool just to be able to not to do it. And you can see the source right in the browser window and see what the page is carrying within it. So that's always a nice little thing to have. Only took us 2 lines of code, so we figured why not. Okay, so you can do comment lines. You can change your URL extensions. You can do things with meta tags. cookies, client-side scripting languages. So here's some error response code information, so you can see what type of server it's running. A lot of times you could tell what type of system it is just by looking at the cookie and the type of cookie it's sending. If you look at the authentication credential itself on what it's named, the values it is taking, the length, you could tell what type of system it is. 90% of my job, as I do it for the most part, is like discovery. Once I know what the system is and what it's doing, chances are it's a walk just to exploit the system. The hard part is trying to figure out what the thing does. And that's how we built the tool, basically to figure out what things are and what things take in. Without that knowledge, there's no way you're going to be able to exploit the thing. And so you could look up for locked accounts, failed accounts. Let's see here. We showed forced browsing. Saw all that, common directories. Let's see. So yeah, so we could, again, URL tampering. You can do overflows. Can do all those attacks. Actually, what I didn't cover actually in depth was cross-site scripting. And let's see, how much time do I got? I've got a couple of minutes. Cross-site scripting, I'll just, let's see here.
Like 25 minutes.
I have 25 minutes? Holy crap. Okay, so cross-site scripting. Basically, we see those every day on VulnDev, on BugTrack, on WebAppSec. Everyone's got a cross-site scripting vulnerability. The problem with the vulnerability is it's not really well understood. And since it's not understood, it's very hard to write a scanner for it. If anybody has a really good scanner for it, I definitely want to see it. So what is cross-site scripting? It's very hard to put it into manageable terms, but I'll do my best. Basically, what happens is if you can get client-side injected code to echo out from the system and execute a scripting language like JavaScript, VBScript, Java, or whatever, you can, for that moment in time, when it actually executes on the output, that code is that system for that moment in time. So for instance, HTML auctions are vulnerable to this, webmail. Actually, everybody's vulnerable to this. But for instance, webmail is a good example. If you send in an HTML mail to someone, they read that mail message, okay? It has some kind of script tag in it. Let's take the very basic example. That code executes, and let's say it's hotmail.com. It executes as Hotmail for that moment in time. So for that moment in time, it executes with the same privileges as hotmail.com. So in the world in itself, it has access to the cookies, it has access to all the functions with that system because it's actually reacting as the user. Beyond that, it actually has control over the whole browser, and you can actually leverage attacks further into the system because no browser is 100% secure. So in and of itself, that's what cross-site scripting is. Getting the script is like just a means to an end. Basically what happens is if the system echoes what is interpreted JavaScript, it's vulnerable, okay? So that's where the alerts come in that everybody sees. So as far as the scripting languages, here they are. There's JavaScript, Java, VBScript, Flash, and all the DHTML. So let's see here. So what can happen when you're cross-site scripted or one of your users is cross-site scripted? Well, they can trick a user into re-logging in. This happens a lot. You can compromise authentication credentials. You can load dangerous or malicious ActiveX. I recently heard that somebody wrote a netcat in ActiveX. So that's got to be spooky, man. Imagine getting cross-site scripted. You got some nice little JavaScript, exploits your browser, you get netcat on your system in about 2 seconds. That would just not be good. You can redirect a user. So actually, I see a lot of spammers and stuff and other pornographers and stuff actually redirecting users using JavaScript where they don't normally have access. You can crash a machine or a browser. Yeah, there's the ActiveX netcat one. Let's see here. So the remote launchpad. So when JavaScript executes within the browser, you can actually take control over that user. So you can actually make that user do whatever you want. You can have them submit JavaScript to somewhere else. You can make them post to a web form. You can make them do whatever their machine can do. JavaScript gives basically unlimited access, and you can find a browser hole, you can have even more. So as far as CSS execution goes, there's actually 2 types. There's the one you click on, and there's the one that auto-executes. The ones that are particularly dangerous are the second one. Basically, you'll see a lot, more often than not, you'll see the click to activate ones, where you have to click on a link to activate. Those are the ones you'll commonly see. Those are not persistent, Okay? The ones that are persistent, that auto-execute, which require the user to do nothing, those are the bad ones. Those are the ones that, where HTML may come in, web auctions, anything with HTML. I've seen, banking systems where, if you want to fire a question off to, the account manager or something like that, you send some little message to them and you can JavaScript it, so all of a sudden you become your own account manager. So you can run evil JavaScript on load. Okay, so now here's where it comes in. Basically, you can get rid of most cross-site scripting exploits by the less than or greater than, rip and replace. Basically, you replace the less than and greater than signs with HTML entities. That'll take care of most of your problems. But it doesn't solve the problem for the systems that want to allow their users to implement HTML. Okay, the reason we see a lot of filtering systems try to allow or try to separate HTML from JavaScript. The problem is that I think it's become pretty futile. Basically, if you want to take my word for it, if you allow your users to add HTML into a system, it's cross-site scriptable. I don't care what anybody says. It's cross-site scriptable. Okay, if you're allowing HTML in, it's over. So manage your risk. Okay, so here that was a list of all the dangerous HTML. Here's a list of the dangerous attributes. Let's see here. We already did that. Did that. Did that. Did we do all this? Okay, so just sum everything up. Actually, I'll do two sum ups. When you're securing a web application, I'm not going to tell you that you're going to be able to make your web application secure in any conceivable amount of time frame, but what I am going to tell you is a few quick little tips to help the security of your site so it's not easily penetrated by every 17-year-old with a browser. Do not trust client-side data of any type. Basically, if you're receiving data, don't trust it, know what you're expecting to receive, and do everything you can to sanitize it and make sure it's actually valid data. When you are accepting data of any kind, make sure you escape and filter all input and output. And then make sure you set up good parameter allow lists on what you're expecting to receive. Don't use what you're not expecting to receive. You keep as close to that, you'll be a lot better, you'll be a lot happier. As far as the tool goes, it's available now. It'll be available on www.whitehatsec.com, probably by the end of the day. I believe it's already up on community.whitehatsec.com. If you have any trouble with the tool. Everything aside, basically the tool is very beta. Basically it's just, we work with it every day and fix bugs in it every day. And working with HTTP and HTML has been just a pain because loose HTML is everywhere. Everybody's got a different style of HTML and a different version of HTML. HTML 1.01, 1.02, DHTML, XML. I mean, who could figure it out? And people have quotes, no quotes, single quotes, double quotes. So it's a constant chore. So hopefully if you're a half decent Perl programmer, you'll be able to get by whatever bugs you see. If you do find a bug that's pretty bad or even just an annoyance, let us know. We'll fix it as fast as we can. Be happy to do that. And we'll be continuously updating as we find new stuff and new ideas. Somebody just gave me the idea today that I should build a front end to front page extensions within the tool, which I can certainly do. So I think that's about it for me. Oh, questions first. Anybody with a question? I couldn't have covered everything that well.
I have a bunch of questions.
Okay.
The first one is, does the Ripper tool support iframes and or multiple forms?
The question was, does Ripper support iframe and multiple forms? Basically, iframe pulls in data from another target. You'll have to go to that target to get Ripper to function in that environment. Basically, it takes one page and rips up all the forms so you can see it, and it will support multiple forms in line.
So you have to go to the target.
Right. So.
And what about if I have a link that's a get string with parameters? Will it be able to parse that out and show it to me in some form?
Not yet. If it's a form, that's the only thing it'll rip in. The question was if he has a link that's a CGI, will rip and reroute be able to function on that? Not yet. We have plans for that. But basically what you have to do is you have to just use rip and rewrite, just the basic stuff. Put your target in, set your request method, put your parameters in, and that's about it.
Does it identify those?
It won't parse it, but you can certainly just modify any form you want to put in your parameters in there. It's just generic, so you just put in whatever you want.
But it will show up in the Spider.
Oh, Spider will catch it, absolutely, but it won't go into rip and rewrite mode with that.
And do you have any plans to script CSS tags with the Spider?
CSS is, we're still working on the right methodology. Okay, the question was, are we planning on any CSS scanners? The answer is yes, we are. The other answer is it's very hard to do an effective one. We see a lot of CSS scanners that just shove arbitrary data into parameters and give you a billion responses, but then you have to click on every single one, and then what was the point of the scanner at that point? So we're working on one right now, but it's going to be a little while. We'll work as fast as we can on it, but yeah, we are. Any other questions? No? All right, thanks everyone for coming. Appreciate it.